Guys, in this video, we will be coming up with two examples and two exercise sums from chapter 9. Now, first let us get into example 3 from page 199 if I'm not wrong. Yeah. Now, the question is, an observer 1.5 meter tall is 28.5 meter away from a chimney. Now, let us take this line as chimney and this we can consider as ground. An observer of 1.5 meter is in the distance of 28.5 meter from the chimney, and the angle of elevation of the top of the chimney from her eyes is 45 degree. Now this is the angle of line of sight, and this is the horizontal line. And this line is line of sight. Now, in we have a value that this angle is 45 degree. Now, we have to find what is the height of the chimney. That is, this whole part we have to find. Now, we have this value to be 28.5 meters. And if we consider this as a triangle, this will also be to 28.5 meter. And this part will be 1.5 meters. Now we have to find this part and add it with 1.5 meters so that we get the height of the chimney. Now first we can take this as a triangle. Let us name it first. A here, B, C, D and D. Now in rectangle, B, C, D, E, the lengths are 28.5, 28.5 and the breadths are 1.5, 1.5. Now coming to the triangle AEB. In triangle AEB, we have the angle here. Now we have to find this part, that is AB. So to find AB, we can use tan 45 as we have to find the opposite while adjacent is given. Now tan 45 is equal to AB, that is this part, and BE, this part. Tan 45 is 1 as we know. So 1 is equal to AB is unknown and BE we know it as 28.5. Now if we bring this here, we get 28.5 to be equal to AB. That is AB is equal to 28.5 meters. Now to calculate the value of AC, we know that AC here is equal to AB plus BC. Now AB is 28.5 meter as we have found, and BC is 1.5 meter already we know. So AB is equals to 28.5 plus 1.5, which is equal to 30 meters. Now the height of the chimney is 30 meters. And that's it. Next we can get into example 4. In page number 200. Example 4 in page number 200. The question is, from a point P on the ground, the angle of elevation of the top of a 10 meter tall building is 30 degree. Now we can take this as the 10 meter tall building, maybe somewhat lesser. We can take this as a 10 meter tall building and this as the ground. From a point P, we can take this point as P. On the ground, the angle of elevation from the top of a tall building is 30 degrees. So top of a tall building here from point P to the building, it is 30 degree. Now a flag is hoisted at the top of the building. Now here a flag is hoisted and the angle of elevation of top of the flagstaff from P is 45 degree. That is from the top of the flagstaff and with the point P, the angle formed is 45 degree. Now find the length of the flagstaff and the distance from the building from the point P. Now we have to find this and this. Now if we notice we have two triangles with the same base. Now we can name it as A, B, C, D. Yeah, A, B, C, D. Okay. Now if we see A, D, C and BDC, both triangles are standing on the base DC. So the base will be common for the both triangles. So with the help of the triangle BDC, we can find the base first. Then with that base, we can find the value of AC. And if we subtract BC from AC, we will get the value of AB. So that we get all the answers as in the question. Now, first let us go to triangle BDC. In triangle BDC, we can take tan 30 itself because opposite by adjacent. So, tan 30 is equal to opposite BC is equal to 10 divided by DC. Now, tan 30 is 1 by root 3. So 1 by root 3 is equal to 10 divided by DC. Now if we cross multiply, we get DC to be equal to 10 root 3 meter. Now we have got the distance between the point P to the foot of the building. We have answered for the one question. Now for the second question, that is the value of AB. First we have to find the value of AC. Now let us take the triangle ADC. In triangle ADC, we have tan 45 to be equal to AC divided by DC. Now tan 45 is equal to AC divided by DC is 10 root 3, we know. Now tan 45 is 1. If we bring this here, we get AC to be equal to 10 root 3 meter. Now to find AB, we have to subtract BC from AC. So let us erase this part. Now AB is equal to AC minus BC. That is whole minus this part, as we know. AC is 10 root 3 meter and BC is 10 meter. Now here 10 is common, so we take it out. Here if we take 10 out, there is root 3 remaining. Here just 1, nothing, so we write it as 1. And this is the answer. The height of the flagstaff, that is AB, is 10 into root 3 minus 1 meter, whereas the distance between P and foot of the tall building is 10 root 3 meter. Now we'll go into exercise sums. Here, till 5th sum we have seen in the previous video. If you haven't watched, please do watch. And 6th sum in exercise 9.1. Now 6th sum is A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. Now we can take this as the building, which is 30 meter. A boy is standing on a point from some distance. So we can take this point and he is standing here. Now the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree. Now let us take first, he is 30 degree, it is 30 degree. And it is changed here. This is the horizontal line, and it is changed when he moves. The angle turns into 60 degree. So this is 30 degree. This is 60 degree. When he stood far, the angle was lesser, and when he came nearer, the angle got greater. Now find the distance he walked towards the building. We have to find this area. First, let us name it A, B, C, D, E, F, and G. Now, for this also, we have a same base, that is BF for triangle AGB and AFB. So, first let us find this and this part will be equal, and the whole part will be equal to this whole part, and this is equal to this. Now first let us find the whole part, then this part, and if we subtract we can get this. We don't have any other way. So first let us go with in triangle AFB, we have opposite, we know the value of this, and here it is given that that boy is 1.5 meter tall. Now let us come here. This part will also be 1.5 meter. Now to calculate this measurement with this triangle, we need only this part and not the whole part. So first let us subtract. So 30 minus 1.5, this part is 28.5 meters. Now we know that in triangle AFB, we have AB as opposite and FB as the adjacent for angle 30. So tan 30 is equal to AB divided by FB. Now tan 30 is 1 by root 3 is equal to AB is 28.5 meter as we know, divided by FB we don't know, so we keep it as such. Now if we cross multiply, FB is equal to 28.5 root 3. Now we have got this value. Now we have to calculate this part. So to calculate that part, we take in triangle AGB, we have AB by BG equal to tan 60. So tan 60 is equal to AB divided by GB. Now AB is 28.5. Before tan 60 is root 3 as we know. AB is 28.5 and GB is unknown, so we keep it as such. Now if we bring this here and bring this here, we will get 20 GB to be equal to 28.5 divided by 3. Now if we rationalize, we get GB to be equal to 28.5 root 3 divided by 3, and if we cancel we will get 9.5 root 3. Now we have this point to be 9.5 root 3. Now to get this part we need to subtract from the whole part minus this. So Now, we know that FG can be calculated by subtracting GB from FB. So, FB is 28.5 root 3. GB is 9.5 root 3. Now, if we subtract it, we will get 19 root 3. And that is the answer. 19 root 3 meters is the value of this part, that is FG. And that is what is asked. Now, we have done. Now, let us get into 7th sum in exercise 9.1. Exercise 9.1. Now the 7th sum is, from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are. Okay, first, now let us take this as the high building, that is 20-meter high building. This is 20 meter, and a transmission tower is fixed. We can take a transmission tower, and from a point, let us consider this as ground and this as a point P. From here, the bottom and the top. Now, the bottom has 45 degrees and to the upper part it is 60 degrees. Now, we have to find the height of the tower. Height of the tower, not the whole thing, the tower. Now, for this also we have the same base. First, let us name it A, B, C, D. Now, we have the common base, that is BC. Now, let us first find the base, and with that we can find the whole part, then subtract as usual. So, in triangle BDC, we have opposite and we have to find adjacent. So we can use tan 45 is equal to BC divided by DC. Now, tan 45 is 1, as we know. 1 is equal to BC value 20 meter. So, divided by DC. Now, if we bring this here, we get DC to be equal to 20 meter. Now, this part is also 20 meter. Now, we have to find the value of whole thing. To find the value of AC, we use triangle ADC. So, in triangle ADC, we have a base and we have to find the opposite side. So, tan 60 we can take, as we have to find adjacent while opposite is given. So, divided by AC by DC. Now, tan 60 is root 3 and the value of AC is unknown, so we can have it AC itself. DC is 20 meters, so we substitute it. Now, if we bring this here, we get 20 root 3 to be equal to AC. So, that is, the whole part is 20 root 3 meter. This is for this and this is for this. Now, to find the value of AB, we subtract BC from AC. So, to find AB, we are subtracting AC and BC. Now, the value of AC is 20 root 3 minus BC is 20. Now, 20 is common here. If we take 20 common outside, we get 20 into root 3 is left out here. So, here nothing. So, minus 1. So, this is the answer. And for more videos, do subscribe my channel and like and share my videos. Bye.